Fine. Good. Ready? Okay. I'll give you the quizzes at the end of the class, okay? Because we need to see the topic first. This topic is not going to be in the partial exam. It's going to be on this in the next quiz. But this is basically a continuation of the previous topic. Okay? The topic is called basically differentiation rules. But before we start, you need to understand what differentiation means. Basically, the process to find a derivative is not just called derivating or derivation. That doesn't exist in English. We're going to call the name differentiation. That's the name to finding a derivative here in calculus. Okay? And basically, the process is when you have a function f of x, you apply the process, limit definition, or the rules to find a derivative. Okay? But the idea here is that using these rules is a way to simplify the process. In what way? In that we're going to forget about the limit definition and we're going to use these rules to make it a little easier. Okay? But before you ask, you cannot use these ones in the exam. In the exam, you need to use the limit definition. Okay?
So this is what you told us that was the table with less steps.
So the idea is that this process allows to find the derivative, differentiation, in 1 or 2 steps instead of using the entire limit definition. But the problem is that the function will be more complicated.
So we will take more or less the same time.
Depends on the function.
Is this exactly as the other process, or are they different?
Are they what, sorry?
Are they equally exact? Like,
oh yeah. You apply the limit definition for a final function. Good. Can I continue? Okay. Fine.
No, wait.
Okay, fine. There are 15 rules, more or less. 15 rules that we're going to use, but today we're going to see the first 4, the easiest ones. Tomorrow, the other ones, and on Wednesday, the last ones that we're going to practice, okay? So the first one, the first rules that we're going to see today are called algebraic rules. Fine. The first rule is called the power rule. Okay? In this case, for example, imagine that you have a function of the form y equal to x to the n. That n could be any number. Positive number, negative number, fractional number, etc. If you have the function like this, x to the n power, then the rule says that the derivative y prime of this is going to be n times x to the n minus 1. Okay? So in this case, for example, the exponent becomes the new coefficient of the function, and then to the new power, you subtract 1. Okay? We're going to do the examples. Yes? Yes? Yeah, we'll do examples. We'll do examples, don't worry. So first I need to see the rule, and then we'll go to the examples, don't worry. Fine. The second rule is called the constant rule. Exactly. If the function is y equals to a constant, what do you mean a constant? A number. Any number. The derivative says that y prime, the derivative is going to be always equal to 0. Okay? So if your function is a constant, that is no x's, no variables, the answer is going to be 0, the derivative. The third rule is called the constant multiple rule. In this case, for example, if the function is a constant multiplying a function, what function? Any function, not just this one. It could be trigonometric function or something like that. The derivative is going to be y prime, which is the derivative, equal to the constant, we leave it, times the derivative of the function. Depends on the function, of course. Yeah, times. The little point means times. The constant times the derivative of the function. And the last one for today is called the sum and difference rule. In this situation, if you have a function that is composed of an addition or subtraction of functions, the derivative is going to be y prime equal to the derivative of the first function plus or minus the derivative of the second function, and so on. In this case, we can have a lot of terms. Okay? Those are the rules for today. Now, the good thing about this is that, if you remember, like I told you in the first day of classes, there will be a formula. So you don't need to memorize these formulas. You need to know how to apply them. Of course, since you're going to use them this partial, for this partial exam, there is no formulary. The formulary is going to be from the next quiz onwards, by having these rules. Good. Can I continue? Yes. Let's try to do some examples.
¿Se le hace fácil, profe?
What?
Yes.
No, it's this. Okay. Good. In this case, for example, we had the first one. It says y equal to x to the fifth power. X to the fifth power. Instead of using the limit h approaches 0, all of that, we're going to use the rule directly. This form, x to the fifth power, is this form. Now we need to apply the rule. The derivative is going to be 5x to the 4th power. And that's the answer. Power becomes the coefficient. The new power is the original minus 1. The power becomes the coefficient. Correct. Okay? Yes?
Y si hubieras puesto entonces todo en la límite de...
You have the same answer. Also a bit more complicated because it's a big power, but yeah. Okay. Next one. Another example. Same rule. F of x equal to square root of x. In this one, for example, if you observe, there are no rules for square roots. But if you remember from Math 1, there is a way to rewrite this square root into a power. Yes. So you need to rewrite x to the 1/2. So now you have the form x to be in again.
Yes, sir.
And then we apply the rule. So f prime of x is going to be 1/2 x to the what? 1/2 minus 1? Minus 1/2. But The problem is that I cannot leave negative or fractional powers as answers. I need to rewrite back. So now, if you remember, if the power is negative, the variable goes down. If it's fractional, it becomes a root. So it's going to be 1 over 2 square root of x, which is the answer.
Which rule?
To rewrite,
En el examen que vamos a hacer por el parcial, tenemos que poner link de trabajo.
okay. Just so you remember the rules to rewrite expressions, like they use there. If you have x to a fractional power m over n, is going to be the n becomes the index, and the n becomes the exponent, and vice versa. And the other one is when you have a negative power, it becomes 1 over x to the positive power, and vice versa. Okay, so that's what I did there. I rewrite so I can have the way, the form of the function, and then I rewrite back. So I don't have negative or fractional powers. Okay? If you remember in your quiz you had something like that in your exercise, so that was the answer. Now, if you wonder, for example, in the partial exam, can you use these ones? The answer is no, you cannot use them. The instruction will say, find the derivative using the limit definition. But you can use the basic rules to verify your answer. So the rest of the exercise is correct. What do I mean by that? Because in your quiz, for example, some of you, well, many of you, got the derivative wrong. So the rest was wrong. Well, not completely wrong. I just put half points. In the partial exam, if that happens, then you can verify your answer, get the correct answer of the derivative, and work with that instead of the wrong one. So you haven't lost the points for the limit definition and not for the entire exercise. Do you see what I mean?
Yes.
Good. Another example for this same power rule. Let's say that I have g of x equal to 1 over x to the cube. Again, there's no rule for divisions. Even if you have like this, there's no rule for divisions. I need to rewrite. How can I rewrite this? Using that x to the minus 3. And then we have the rule. We can apply it. G prime of x equal to what? Minus 3x to the minus 4, yeah. And then I rewrite minus 3 over x to the 4 pi.
Tienen que quedar siempre así.
Minus 3 minus 1 is minus 4. You should have it.
Profe, siempre tienen que quedar con exponentes positivos.
Yeah, always. No fractional powers, no negative powers. You do it right. With a root or with a fraction. At the end. The answer. Okay? That's for the first rule. Power rule. Okay. For the second rule, for the constant rule, that's simple. For example, if you have y equal to minus 5, the derivative would be what? 0. According to that, it's going to be 0. If you have, for example, something a little trickier, f of x equal to 3 pi. What's the answer?
0.
0. Why? Because pi is a number, not a variable. So, 0. Yeah? That's the constant rule. What happens if I have, for example, y equal to 3x to the 6th power? Now it's a constant multiple rule. We have a constant multiplying a function, which is x to the 6th power. So now it's going to be y prime equal to, if I apply the third rule, will be what?
6 times 3.
Well, the 3 stays the same, times 6x to the fifth power. I apply also the power rule for this, so the 6. And then I can simplify. 3 times 6? 18x to the fifth power. The third one. Another example. Let's say 5 over x to the square. What happens here? Can I rewrite this? Yeah, how? How do I rewrite that? 5x to the minus 2. So, again, apply the constant multiple. The derivative is going to be 5 times the power rule, which is minus 2x to the, according to the power rule, minus, no, minus 3. So, minus 10 over x to the cube. That's the answer.
No es al revés, porque 5 por 2 no sería 5 x a la menos 3 por menos 2. Es lo mismo, pero no es 5x a la menos 3 por menos 2. Según la regla.
Which rule?
La primera.
Now the power rule is only for x minus 2. That's you apply the power rule for that. There's a constant. You leave the constant. And you put x to the minus 2 minus 2 to the minus 3. And you rewrite it. So we're applying the constant multiple, but then at the same time, for the x minus 2, we're applying the power rule. So we're combining the two rules. Okay? Questions? No? Good. The last rule. Can I read this? Yeah.
Y los resultados se ponen igual a nada más eso, o cada uno se pone f de la regla.
Dependiendo, entonces, si dice gx, lo vas a poner gx.
The name of the function. Yeah, you need to put it. You just put, for example, you forget to put this and just put 3 pi equal to 0, then it's wrong. Good. Another example. One single warning. Next one you go. It says. Okay. To apply number 4, the sum and difference, we need to apply also the other 3. Okay, because for the sum and difference is the derivative of each one, but for each one we need to apply either the constant multiple rule and the constant rule and the power rule. So we can combine all of them at the same time. That would be the idea. If we want to apply the limit definition for this, it would be a lot more complicated, so that's not the idea. We need to apply these rules to do this and find the answer. Here, I have all of this in my function. 5x to the cube plus 2x to the fifth power minus 1 over square root of x plus 4x minus 3. What's the first step?
Hacerlas por separado.
Before that. Yeah, like we did here. The very first step for this kind of exercise is to rewrite everything. Rewrite. But rewrite everything if you can. If something doesn't need to be rewritten, you need to just leave it like that. If you need to rewrite, for example, this one, you leave it like this. You need to rewrite this one, you rewrite. Don't find derivatives yet. Just rewrite everything. So, again, first step, rewrite. So, f of x equal to, do I need to rewrite this one? No. So I leave it. Do I need to rewrite this one? Yes. 2x to the minus 5. Minus. Do I need to rewrite this one? Yes. Yes. Plus. Do I need to rewrite this one? No. Do I need to rewrite this one? No. No. Okay. Listen, and listen well, please. Common mistake that students do. They try to find the derivatives in the beginning. No, you need to rewrite everything first. That is, this one doesn't need to be rewritten, leave it like that. But leave it like that. Rewrite this one, leave this one, leave this one. Don't find the derivatives yet. Because if you combine derivatives with just rewriting stuff, it's going to be wrong. So it's rewrite everything, and then after that, we apply the rules. Apply differentiation rules. All of them. F prime of x. Derivative. Derivative of this. You can skip the steps if you want to, but let's do it step by step by now. 5 times 3x to the square. If you're that good and want to simplify to the beginning and say that it's 15x squared, it's fine. Do it. Next one. Plus. No, actually, I recommend you do that. Huh? Try to. Yes, now it's going to be too much. Next. 2 times minus 5x to the minus 6. Okay? Next one, minus 1/2 x to the what? Minus 3/2. Why? Because minus 1/2 minus 1 is minus 3/2. You cannot do it mentally, it's a calculator, so do it. Plus 4, the power for x here is 1, so it's going to be 1x to the what? 0. You subtract 1. You subtract 1. And the derivative for this? 0. Okay? I apply the rules. Last step is to simplify and write the necessary back. So, f prime of x. This is going to be? This is going to be? This is going to be plus 1 over 2 square root of x to the cube. Why? Because of this. Negative denominator, fractional root. Plus x to the 0 is 1 times 1 times 4 4, and the 0 doesn't matter, so that's the answer.
Oh my god.
Dios.
Can you do this in a single step? Yeah. And that's the answer. Derivative of the constant, that constant doesn't have an infinite variable. The answer is 0 of the derivative. And apply the derivative. Because I need to find the derivative of each one individually, and the derivative and apply the rules. Good. Questions? No? Sure? You need practice for this. Yeah. Jimen. Okay. It's not that complicated, but you need practice. You need practice, a lot of practice. Okay? Because these functions are easy. We need to start increasing the pace of this. Good. Let's do another one. Can you read this?
Yes. Vamos. Es que se arde porque no me gusta que digan de primero. Pero de primero ingreso pasa esto.
Okay. Now the example is more complicated, but this example is basically like what I was going to do in the exams. Okay, so that's what I'm doing it. Just wait. Just wait.
Sí, hay como el...
Don't worry, we have plenty. Okay, fine. In this one, for example, it's a little more complicated because the function is not in the way that I can apply the rules directly. We need to rewrite and simplify. We can before the derivatives. So, rewrite. That's the first step. You have what? You have this, and that. We need to rewrite the square root into something that can be done. We have 5x squared times what? X to the what? To the 1/2. Minus 4x to the cube times what?
X to the
1/3. Plus 2 times 3/2. Over 2x to the 1/2. Okay? Now I just rewrote the powers. We haven't finished because we have products and divisions. So far we haven't seen rule for divisions, not yet. So I need to get rid of this algebraically. What happens if I have same bases, different powers? How can I multiply them? You add them. So it's going to be 5x to the what? You have 2, 1/2. 5/2. Minus 4x. You have 3 and 1/3. 10/3. Plus 2x to the 3/2 over 2x to the 1/2.
¿Cómo sacaste el 10?
La suma de 3
is 9/3 plus 1/3 is 10/3. Yeah? Okay? I haven't finished yet. I have a division, so I need to do something. What can I do with this and with this 3? Separate them. Separate this over this one, this over this one, this over that. Okay? Remember. Si ahora en el examen. Van a pasar.
Ya cuando si lo restas, ¿no haces la ley de resta o no?
¿Sí? ¿La restas?
Okay. When you have one monomial, you need to divide each one of them by that. So if I divide this by this, I subtract the exponents. So now you have 5/2 x to the 2 minus 2 x to the 10/3 minus 1/2. What?
17.
17 what?
Over 6.
Yes. Plus 2 over 2 is 1. X to the just x.
Sí, porque 3 y 2
Yeah? Now I finish simplifying. Okay? Listen, the complicated part of this is not the derivative. The complicated part of this is this. That's why I told you the first day of classes. If you pass algebra just with 70, something like that, si apenas pasaron mate 2 o 3 o 4 sin saber hacer esto bien, ahorita decirles que no van a pasar. Espero que sí. Espero que sí. Porque la verdad, así van a venir. Así van a venir. Y si no saben simplificar, si no saben ver esto, si no saben simplificar esto, la verdad, y no es por asustarlos, es que ya todos mis grupos también. Si no saben hacer esto, y es así siempre, no van a pasar. Porque es esto y aparte derivar. ¿Sí? Entonces aquí el consejo es más bien, si quieren que les vaya bien, primero guarden su atención. Y segundo, hay que practicar mucho lo de simplificar, porque van a simplificar de aquí en adelante todos los temas. ¿Sí? ¿Qué vamos a hacer?
Profe, y ahorita, más adelante vamos a hacer como dividir.
Sí, pero de hecho vamos a ver que sí hay una regla para división, pero no me va a convenir. Me conviene mucho más simplificar, aunque me tarde más, pero es mucho mejor para después derivar. Si yo aplicara la regla de división de derivada para esto, nunca acabas.
Es largo.
Largo. Vamos a ver el viernes, profe.
O sea, tenemos parcial y luego
No, no hay curso el viernes.
son 15 reglas en total.
Más o menos.
Y hay que, va a haber hoja de.
Sí, formulario hay. De pronto van a usarlo.
Nada más a ver.
Okay. Derivative. 5 house, 2x. Let's try in single step. 5x minus 2x to the 76. 17. There's x to that 11, 6. Plus 1. Why? I just skip one step. Which step? This. What did I do? The 2 multiplies the 5 house, the answer is 5. X to that, 2 minus 1 is 1. 2 times 17, 6 is 34, 6, which is 17 thirds. X to that, this minus 6 over 6, 11, 6. Plus x, derivative that we did, is always 1. So 1. And then at the end, we need to just change this one. 5x minus 17 thirds, 6 root x to the 11 plus 1. That's the derivative. Again. Try to, little by little, doing this mentally, because if not, you're going to waste all the time doing rule by rule. So, practice. Questions? No? Yeah. This becomes a coefficient, multiplies the 2, becomes this. This, subtract 1, becomes this. Check your rules. Okay. Now we have time. We're another one. Yeah. Okay. Simple one. Try it. Right, simplify, derivative, find the answer. Before I forget, tomorrow bring a 3.2. 3.2 has 50 exercises. It's going to be due Monday, because on Thursday you have exam. So, if you can, start practicing with that or during the weekend, because it's the Monday. There are 50. No.
No, tener un repaso antes del examen.
In class, no.
Ay, el repaso sí va a tardar.
There's a review, and I did a review Saturday.
Profe, en este caso con el x al cubo sobre 2 es igual que si fuera variable abajo, saldrá. Entonces,
Rewrite. There's a coefficient there. Rewrite. First rewrite, remember? The answer? No.
No, la primera.
Rewrite? The first one? No.
un medio por 3x al cuadrado.
Okay, I'll help you a little with this. Okay. If I rewrite this x to the cube over 2, how can I do it? Rewrite. 1/2 multiplying x to the cube. This 2 is 1/2 actually. It's 1/2. So it's 1/2 x to the cube. You can put it in the middle, you can put it in the numerator. It's the same thing. And this one, if I rewrite, is going to be 2x to the minus 3. Now it's easier.
¿Y ella se puede hacer, no, profe?
Yeah, from the root. Huh? Yeah, but the basic for everything. So you need to study things today, even if it's not in the course. Yeah.
Por ejemplo, no nos va a llegar que dos veces más menos.
Later. Not right now. Later.
Pero sí lo vamos a hacer.
Like in the middle of the comparison.
Pero esta es la regla rara, ¿no? Es como una regla rara, ¿no?
Chain rule? No, class 4.
Es medio.
No, he's asking if you're going to find the derivative after that. Yeah, it's second derivative, third derivative, so on. Yeah. This one? This one? Find then. Answer? What?
3 medios x cuadrado menos 6x menos 4.
¿Qué?
Ah, sí, sí. Yo ya. Me faltó un paso.
That's the answer. Yeah? Good. Questions? No? Okay, fine. fueron 4, pero hay 2 ceros porque Daniel no hizo el examen ni Paola, que no tocó hoy. No calculé sin ellos dos, entonces vamos a dejarlo así. 2. En el examen, por ejemplo, donde más les falló fue en la derivada, a muchos. ¿Por qué? Porque si viene la derivada, por ejemplo, hacia la función raíz de x más 1, por ejemplo, lo que les falló es que me metían el 1 dentro de la raíz a 1 y el que no venía dentro, y otros a la hora de hacerla racionalizar dejaban el 1. El 1 se cancelaba en un principio. Y ya pueden ver por qué no. Este 1 es una constante, se va a volver 0. Lo que me importa es la raíz de x. Sí. Entonces la respuesta era nada más así. ¿Qué es esto? Con las reglas estas. Entonces, se equivocaron en la derivada y lo demás lo tienen de acuerdo a su respuesta, máximo la mitad de cada ejercicio. Está mal, pero bien procedimientos, mitad, cortas procedimientos, entonces la mitad. Pero aún así sí hubo varios reprobados. Bien. Y ahí, pajarito.